Now let's find some logarithms without using a calculator, just using our knowledge of indices. Now, we've been asked to find the value of a certain log. Now there's no equal sign on here, so there's no actual equation that we can fiddle with to tell the story. Now, you can always make an equation. If we're finding this, we could just let this equal, say, x. Let log base 2 of 32 equal x. And now, effectively, we're just trying to find x, aren't we? And we can now retell the story because we have all the elements. We've got the 3 parts that we need. Here we only had 2 parts. So this is a crucial first step in your thinking. Now, if we retell the story, 2 to the power of x equals 32, and then rewrite it, we have this. Now, I know that 32 is 2 to the power of 5. It's 2 times 2 times 2 times 2 times 2. I sort of know that off the top of my head, but if you weren't sure, you should be thinking of 32 as being a power of 2. We get to know those numbers. 2, 4, 8, 16, 32, 64, and it's good to be able to recognise them. So here I could change 32 and say, hey, that's 2 to the power of 5, actually. Now can you see that if both the bases are the same and the 2 expressions are equal, then the index numbers must be the same. So x must be equal to 5, and that's my final line, x equals 5. So I've ended up solving the answer to this problem, which is 5. I can do the same thing down here. Let's let the log base 10 of 100,000 equal x. That gives us something to find, and it gives us the 3 elements so that we can tell the story and rewrite the question a different way. 10 to the power of x is equal to 100,000. So 10 to the power of x is, I know that this is a power of 10. This is 10 to the power of 5, isn't it? Because there's 5 zeros. Therefore, if they've both got base 10 and they're equal, then x must be also 5. Now you might wonder, why have I taught you how to do logs so that we can rewrite something from an index expression, and then I've come back to an index expression again? How have we achieved anything? Well, we're just learning here, and we're learning how to do some without a calculator, so we really get into our minds what it is that something like this is actually asking us. Once they get more complicated, we leave it in log form, and we've got various tricks for simplifying these things and then using our calculator to find out the answer to them. Now, to find logarithms on the calculator, there's a couple of ways that we can do it. We have a button that literally just says log, nice and simple, and the log button means a log with a base of 10 of some number. A is just a constant here. So you can only use this button when you've got a base of 10 on your log. So let's look at an example that does have a base of 10, so we can actually have a practice of using this. 10 to the power of something is 620. Now we want to rewrite this in log form, tell the story, so start by writing down the word log, and then start here with your base. 10 to the power of x equals 620. We've got our funny way of telling the story and writing it round in that loop. Now we have the x by itself. We've actually got something here that we can put into the calculator. And the way that we put it in is we press the log button, which means log to base 10, and then we type in 620, and then we hit the equals button. So let's have a go at that together. Calculator's on, we hit log 620, and then equals, and it tells us that it's 2.79, and we're going to need to round this off. So we can say here that x is equal to, let's say, 2.79 to 2 decimal places. Oops, 2 dp. All right, now what does that mean? It means that 10 to the power of this 2.79, etc., is 620. Let's check if that makes sense. What's 10 to the power of 2? It's 100. What's 10 to the power of 3? That's 1,000. So it sort of makes sense that it's going to be a number between 2 and 3. Now, could you have figured that out in your head? Absolutely not. You really need a calculator to figure this out. Could you have done it any other way? Well, trial and error. I've just figured out that it has to be between 2 and 3. So if I didn't have this log button, it would be such a pain to do by trial and error. You could do it, but it would be really, really slow. You could say, all right, let's try 2.5. 10 to the power of 2.5, what do I get? 316, that's a bit too small. Okay, so I'll try something bigger. 10 to the power of 2.6, and that would be too small. 10 to the power of 2.8, oh, that's a little bit big. You could narrow it down and gradually get to this by trial and error. But this log button saves us from needing to use trial and error and can calculate this really simply. Now, there's another button next to log. So have a look at where there's log. To the right of it, there's another button, ln, ln. Now, this means a log with a base of e of something. Now, we haven't come across e yet, but you can only use this number when you've got the base e. And e is a special number that we're going to discuss later on in this chapter. So we'll leave that one for now and we'll come back to it. Now, while we're looking at buttons on the calculator, let's have a closer look at that log button and have a look at the shift function. That's the little yellow function that you can get by hitting the shift and then the log. Well, the shift button and then log gives you 10 to the power of something. And this is really significant because if you find 10 to the power of something like we did here, it's the exact opposite of finding the log of base 10. So to test whether this is true, our last answer that was in the calculator is 2.79. Let's test that out now by doing 10. Let's do shift log, and it will put 10 to the power of something. And in the little box where you get to put the something, hit the answer button on your calculator. It should put that 2.79, etc. Then hit the equals sign, and you should get 620.